Okay, so before we begin say our main topic, let's discuss or talk about this scalar and the vector quantity. So, gamay lang jud kayong review no on these topics. Scalar quantities are any quantity. So, they are any quantity that has a magnitude. So, magnitude or measure, but no direction. Okay, so scalar quantities are anything or any quantity that has a magnitude but no direction. Let's say, for example, I'm applying a 10 kilonewton force to a box. So there is a magnitude but there is no direction. We don't know which way it goes. Is it going upward in an inclined surface, going to the right, going to the left, or front or back? Now for the vector quantity, so these are any quantity that has a magnitude and a direction. So here in the dynamics of rigid bodies, so we'll be talking about quantities, scalar and vector quantities. So that's why I have a short recap about this one. Another thing also that I would like to talk to you, since dynamics of rigid bodies talks about bodies in motion compared to statics. No, statics talks about bodies at rest. So dynamics is talking about bodies in motion. So here we are going to talk also about acceleration and also the gravitational acceleration. So in the symbol of the gravitational acceleration, G, gravitational acceleration. So in the SI system, so we have the gravitational acceleration to be 9.81 meters per second squared. In the imperial system, or the English units, we have the gravitational acceleration into 32.2 foot per second squared. So these are important things to be discussed or recalled, since we are going to use them from time to time. So the next one is it has a symbol of M, the mass. So in the SI system, we have the grams, kilograms, tons, and others. In the imperial system or the English units, we also have ounces or ounce, slugs, and then the third one I would like to talk is the weight. So the weight is the mass acted by the gravitational acceleration. So the formula for the weight is just equal to mass times the gravity. So for the SI system, our weight is, so we have the mass and the gravity. So generally in the SI system, we use mass into kilograms, multiplied it with the gravitational acceleration of 9.81 meters per second squared. So here you can see that I did not put any quantities but only their symbols or units, just to emphasize something. So kilograms, so in the SI system we have the kilograms meters per second squared, also called as Newton. Okay, so this is the SI unit of force, Newton or kilonewton. In the imperial system, we have the slugs times the gravitational acceleration unit. So so ako lang ginabuta ang units just to emphasize something. So in the imperial system or the English units, we have the weight to become the slugs foot per second squared, or equal to pounds. So in the SI, we have Newton, and commonly we use in the SI analysis of data kilonewton. In the imperial, pounds or kilopounds or kips. Okay, so that's all for these minor reviews.